Everybody, I'm so sorry to be late. I, for some reason, had this in my mind that it was going to be at 11 o'clock, and clearly I was wrong. So thank you for the phone call, Matt. And thank you, everybody, for joining us for number 2 in our GIS informational series for 2025. And we have Sandy Stroud and Richard Kelly here from One Spatial to talk to us about transition guidelines. So thank you guys so much for being here, and the floor is all yours.
Great, thank you. It's really exciting to be here, and as I was pulling together some content for the session today, really just am excited about the future because I think that those of us that are in this space from a vendor perspective or in your seat, there's just a lot of really exciting stuff coming together, and a real clear picture of what transition looks like. I think, just to kind of give you guys a bit of backstory on me. Before I came here to One Spatial as the Director of Public Safety, I was the 911 program manager in for the state of Minnesota. So I did run our EZNet. We were the 911 authority. We did provide the network for all 86 primary PSAPs in the state. But that's really where our responsibility stopped, was at the DMARC of the PSAP. So we distributed a lot of 911 funds, and the PSAPs were very home rule in the solutions that they deployed locally. And so through this work, I learned a lot about, some of those stakeholders that are involved on the network side as a 911 authority, which some that sit in a PSAP may never really have to know or learn. But what we're going to talk about today is why it is important for all 911 leaders to have a good frame of reference on what the difference is between transitional and maybe an end state I3 or an I3 deployment, as you kind of begin this process of moving into procurement of next gen core services. Before I was at the state of Minnesota, I spent most of my career as a GIS professional working in state, local, and federal levels. Spent a lot of time in addressing, but also in public safety and 911. So really, this is something that I've been doing for quite a while, along with my counterpart here, Richard Kelly. And I co-chair the NENA RFP Considerations Committee. So a lot of the stuff that I talk about today will be from somewhat of that perspective, which is, as someone who may be in a position or soon be in a position to be procuring these systems or evaluating proposals on these systems. This will be kind of a helpful space. We are going to talk about a little bit about the transitional document that NENA has. But what I'm also going to do is to add to that document more of a real world operational flair of how this impacts both GIS and 911 as you are deploying a next gen core services system. I'm also going to talk a little bit about how the regulatory guidelines and regulatory rules are now shaping this, and where the standards actually are really important and come into play with that. So just a quick agenda. We're going to do a little bit of an introduction to this topic. I'm going to focus on 3 kind of key areas. The meat of everything is actually in this roadmap section, but I do want to touch on, to set up that conversation, some exploration on where address fields are so important in the transition, the address fields in your GIS data. We're going to talk a little bit about the value of an ESC. And this may be something that you have or have not dug into. We'll talk a little bit about what we did with this in Minnesota, but also this is something that is in that transitional guidelines. And then we'll go through a roadmap and really kind of start pulling together a picture of where all this work that's been done and will be done on the GIS side really kind of comes into play on this 911 operations side. So as I said, there is a information document that was published by NENA. Some really, smart folks came together, both from the vendor side and the operations side to put together some guidance around this transition to next gen 911. So we're transitioning from E911, which is, the markers of that really are a legacy selective router, which aggregates 911 calls for your EZNet right now, the use of an ALI database and an MSAG as your primary source of location truth to route the 911 call to the correct PSAP, and this legacy address format. So we're going from that to a IP call packet. I think of it like a Ziploc bag because this IP packet holds voice, video, text, all sorts of really helpful intelligence, but embedded in that header of that top of that Ziploc bag will be the location information that will be sent from the originating service provider. We'll look a little bit at a transitional call flow and where these transitional elements come into play. But we'll also talk about, and I know Richard touched on this a lot last time, the transition from a tabular-based location database to a geospatial database, and how you make that transition, but also how important these polygons can be in operations. So not just as a transitional component, but we'll talk a little bit about how I use these in Minnesota to help with edge matching. So as I said, we had 86 primary PSAPs. I had 74 data contributors because in many cases, about a third of our PSAPs used a vendor to do their data management. We did deploy a statewide data validation and aggregation solution that every single local data contributor could use to validate their data. There were 8 phases of validation. What we also did is we allowed PSAPs to use and submit ESEs instead of a PSAP boundary and separate service boundaries. We had the ability to interpolate from the ESC the separate PSAP boundaries and the emergency service boundaries. And how that really helped the data contributors was they had to do edge matching once. So the edge matching was done from ESC to ESC at the boundaries, and then ensuring that the topology is set inside. It really helped cut down on the amount of time it was going to take to build their boundary files. So this is something that is in the NINA recommendations document. I can also say this is something that we've done operationally, and it has saved a huge amount of time. When we get to that section, we'll talk a little bit more about the value of this from an ongoing operations perspective too. So there are some really important standards that you want to consider when we're thinking about transitioning from E911 to next gen 911. And this transition is not a light switch. So it's going to probably be in a couple phases, and there could be 5-7 years between each of these phases. There could be as short as 6 months to a year between these phases. So that's where you want to really kind of understand and prepare better for the needs on the data side. So when we look at these important standards, definitely, and Richard talked about a few of these last time, the NINA standard for NG911, the data model. This is really going to inform and tell you the structure of your attribute table. So what are the columns? What are the column widths? How many characters? What field type? The CLDXF format, you're going to hear me talk a lot about that today. This is a standard CLDXF. It's on version 2. This informs you as a GIS data contributor or a 911 authority how those elements inside that data structure that the data model puts out, what those need to be represented as, so domains. It'll tell you whether or not a abbreviation is appropriate or it has to be fully spelled out. This is really important, and we'll pull all this together when we talk about the roadmap and we look at how this data comes together with the data from the telecommunication providers. The I3 standard will be important because it does really define how data elements will be used, and it does define the concept of a valid address, which may be a little bit different than what we think about on the GIS side. There is another standard, it's not a NINA standard, it is a standard from IETF, which is the International Engineering. This is PIDFlow. So PIDFlow can be scary. We will break it down. I will demystify this for you. It's actually not very scary. It is, when you look at it at its core, it is a blend of the data model and CLDXF together. And so once you can kind of look into an actual PIDFlow object, and we'll look at that today, you begin to see how this all comes together again. Now, it's also going to be important in transition to remember that we do have data exchange standards for E911. And this will come into play when we're talking about the MSAG and the ALI, specifically the MSAG conversion service. So there is a functional element that will be part of that alphabet soup of acronyms that are part of a core service package in transition called an MSAG conversion service. And actually, we'll take a look at where that comes into play. This is a really helpful kind of walkthrough of a transitional call flow, and then you'll be able to see the difference between a transitional call flow and more of an I3 end state call flow. There is nothing wrong with either. I would say that as a 911 authority, I would suggest that pretty much everyone is going to go through one transition to another, and we'll go through both. So I would suggest, if you have not made that transition to core services yet, this is probably what you're looking at. If you have, you can kind of, understand better where your system that you've procured looks at. So we always start with the 911 call. Now, there are some nuances to this, and we've been digging into this a little bit recently, especially with our wireless providers. Typically, the primary reference that is used to route a 911 call from a mobile device is that XY coordinate. Now, sometimes it can take as greater as 9 seconds for them to get an actual location of the handset. So that initial coordinate that is sent, it may be a cell sector coordinate. That's a little bit of some information we've been learning. They may also send the location of the cell tower or a dispatchable location, because they are required to do that as well. And that is a civic location. The landline VoIP providers, they will simply send the reference of a telephone number still. So that telephone number, the civic location, comes into the ESRP. If it is a telephone number, that is going to send that to the LDB. So the LDB is really a transitional element. It is not defined by NINA or in the I3 standard. You will not see a lot about an LDB. But you do want to understand what the LDB contains and maybe some of the information about it contains, because that LDB is replacing the ALI database. It is pretty much a requirement to do that, because the LDB has a different type of query that it does. It interacts with the ESRP in a way that the ALI database cannot. Now, it is not uncommon for the LDB to still store the 911 records of all the telecommunication providers in your area in a legacy format. So going back to what I just talked about, that legacy format is probably in that NINA standard for E911 data exchange standards, because it may still be validated against an MSAG. One of the things that we come across very often is that an MSAG conversion service, it's a really bad name because that's not what it does, but that the MSAG conversion service may have to be used between the LDB and the ESRP, because that address may not be in CLDXF. The ESRP needs the address to be in CLDXF so it can send that to the ECRF. So the call goes from the LDB, it may have to be converted. Think of the MSAG conversion service simply as a fully formed address point, road center line table that has legacy elements and your primary elements. and it's going to convert from legacy to PIDFlow or CLDXF or vice versa. So once it has the elements in the civic location in CLDXF, it sends that to the ECRF, which is informed by the GIS data that's being created by all the data contributors in the audience. Now, what that sends back to the ESRP is something called a URI. So think of a URI just like a URL that defines your PSAP name. So that URI is something that will be stored in your PSAP boundary. So we think about our ESCs. There's a lot of information that may have to be added to an ESC if you were to do what we did in Minnesota. But having that URI, it informs the ECRF which PSAP to send that call to. Now, we know, though, that the MSAG conversion service or an LNG may come into play to convert that address or that PIDFlow element back into a legacy element. Why? We're still in a bit of a transition on our call handling side as well. Many will say that they can accept an I3 call, but they may not be able to actually display on the screen for your call taker the PIDFlow object or the CLDXF location. So that may have to use the MSAG conversion service again to translate it back. Now, once our call handling providers begin to make that transition, you may have to use the MSAG conversion service again to translate it back into CLDXF or a PIDFlow object so that it can be displayed. And then again, because our CAD systems are not necessarily standardized as well, there may have to be another point of conversion. So what these conversions should represent to you in your mind is it does you probably wouldn't even detect it, but it does change how quickly that call gets actually sent to your PSAP. It also can represent a point of failure to where if that address cannot be converted, if it's for some reason not in the MSAG conversion service, you may be going back and relying upon a default route. You may be relying upon a policy route. And really, again, all that's going to do is delay the call getting to the right PSAP. So this should help you understand really well, your GIS data plays a role in the MSAG conversion service, in verifying that the LDB data contains the correct legacy and CLDXF elements, and we'll talk about that. But that your GIS data is informing all of it or being used to do that conversion. So what is it going to look like once you can actually get past this transitional core services? This is what I would call a real I3 call flow. And we will talk a little bit about how the FCC is helping this to occur. So one of the major changes you're going to see, there's no more LDB. The 911 location database that has been part of your vernacular for probably your entire career in 911, that goes away. What replaces it is the OSPs become 911 database providers. They have to host their own 911 database of locations, and that is called a list. We will talk a lot about this because one of the important things to remember, and this is where I go back to the I3 standard. The I3 standard has some very specific descriptions of a list. Data cannot live in a list database. So a 911 address, a service order from an OSP or originating service provider, that cannot live in a list unless it has been LVF valid. What powers the LVF? Your GIS data. So that is the same data that's in the ECRF, but this time it is used by every single OSP who has subscribers in your area, 911 authority area. They will use that database to pre-validate any record before it can go into a list. Now, you may hear people say that they have a list. A lot of our wireless telecommunication providers will say they have a list that's just stored dispatchable location information, but it is not a list unless every record in there has been LVF valid. And the truth is that the LVF is not something that up until the FCC passed the report and order, that's really been something that's even been deployed. There are very few LVS actually out in the wild right now. But I'm going to walk you through today why this is important and where you're going to want to really consider standing up an LVF. And it's going to be a lot sooner than maybe what has been done typically in the past. So 911 call gets initiated. That LIS database, whether it's internal to the VoIP provider, whether they use a VPC, whether they use a third-party list for a service, they're going to have to get that location information and embed that in the header of that Ziploc bag, that IP packet. That all happens before the call gets sent to the ESRP now. So when you think about what you're responsible for as a 911 authority, your level of responsibility and cost greatly decreases when you make this transition to an I3 call routing system. You also will see there's a lot less conversions that will happen, which means the call should be going quicker. But the process is still very similar, except we just have the call coming in with the correct location reference. Now, you'll see that the only time it really will be translated is for those few PSAPs that still have call handling equipment that cannot display CLDXF or PIDFlow. And then we still have our CAD vendors that we're going to have to really start working with. So I want to just make a suggestion. If you have questions while we are going through this, I would really love for people to ask questions while we're going through it. I can always go back. So I don't know how you guys want to handle that, but please, if you have questions and you don't want to wait until the end, do not hesitate to interrupt me, put your hand up, put a question in the chat, because this is definitely a lot of information.
Thanks, Sandy, and I'm monitoring the chat for you.
Okay.
No questions so far.
Okay. So I keep talking a little bit about the FCC. I know Richard talked a lot about this last time. We're going to dive into it a little bit more. But, you know, really, as of March of this year, it's been fully codified in federal code that you as a 911 authority have the authority now to request that the telecommunication providers make the necessary changes so that you can comfortably deploy a transitional and then an I3 call routing system. We'll talk a little bit about that, what that is. So really for phase one, this is to deliver the call in an IP packet already. Just to give you a little bit of context of my time with this, when I was with the state of Minnesota, I inherited a ingress network project. And what that means is when I started with the state, we had legacy selective routers that were so past end of state, they had to buy parts on the internet, on eBay. And so we decided, well, we're just going to go out and replace the ingress part of our network. We had an EZNet. It was about 11 years old. We had not procured core services yet. So we just said, okay, we're just going to replace that first part of the network, the part that receives the 911 call. So we went out to bid. We brought in a fantastic vendor to help us with that project. And as we began working through that project and working with our OSPs, no one was signing their agreements. So what did that mean? So we went out, we procured an ingress network, we stood up TDM POIs, points of interconnection. That's where they had to aggregate their calls to. Now TDM was legacy. That was fine, they could continue going legacy. We also stood up 2 IP POIs or SIP POIs. That's where those that had made the update, where they could already convert and send the call in an IP packet, they could just connect to the SIP POI. So after about 18 months, no one was migrating their network. I'm paying for 2 networks at the same time. And what that meant financially was legacy selective routers cost me about 1.2 million a year in Minnesota. The POIs were costing about $750,000 a year. If I had a full transition and I had no one having to send the call TDM, I would only be paying $250,000 a year for network. So it is not an inconsequential amount of money when you are paying for two parts of a network at the same time. And we were really at the will of our OSPs to migrate off of these legacy selective routers to our TDM and SIP POIs. Ultimately, I did have to use our Public Utilities Commission's power. I filed a complaint petition against the OSPs, and we ended up in mediation for 18 months. The first part of the ruling was that they did have to migrate their network, but we were also told we had to go into mediation with them to figure out what IP cost recovery would look like, and we did. So if the FCC's report and order had been passed and these rules were codified, we could have simply just filed a phase 1 request and they would have had to migrate their network within 6 months to a year. So my experiences with that really did help me have a level of understanding of how important this is. But when we get to phase 2, that's where the work that you're doing on GIS comes into play. So for phase 2, and we'll talk a lot about this, this is where, when as a 911 authority, you request a phase 2 request from the FCC, you're going to basically indicate to the telecommunication providers that you are no longer going to be a 911 database provider as a 911 authority. You have the data to where you can stand up an LVF, and we'll talk a little bit about that. But you also are basically saying your expectation is that you are using your ability to request this. You're expecting them to stand up a list database and that they will send the pre-validated 911 location of a fixed device or a dispatchable location in the proper format so that you do not have to translate data back and forth from legacy to end state in that call path. So we're going to talk, as I said, about some address fields before we talk about this roadmap. We're going to talk about ESZs again. So what we're talking about with address fields and your primary address fields, we're going to talk about two different address fields. So for your primary address fields, this is where CLDXF comes into play. We'll talk a little bit about I have some recommendations about phases and approaches to the data remediation. Focusing a lot on CLDXF is going to be really critical as you are doing validation and you are cleaning up the address points in the road centerline data. CLDXF, there are two versions of the standard now. The civic location, this is the street address. This does not necessarily get into those sub-elements yet. And in fact, there's a lot of conversations about how PIDFlow does not necessarily capture every single element that is laid out in the NINA data model. So that is some additional work that's going to have to be done. But again, remember, CLDXF tells you what the data has to look like inside the element field. So for something like pre-directional, the data model is going to tell you the field name. It's going to tell you if it's the inclusionary designation. Well, that's a little caveat, and we'll talk about that later. But then also the type and the field width. CLDXF is going to give you a lot more information. It's going to tell you the definition of that field. So if you've ever wondered what is the difference between a pre-type and a pre-directional, CLDXF will tell you. It will give you examples, but it will also tell you the domain that is acceptable. And so this is something you really want to pay attention to. And this will all come together when we start looking at an LVF. And we're going to look at some PIDFlow and some LVF and where they match and where they don't match and why. But a lot of it does come down to CLDXF and why it's so important. Now, the other address fields we're going to have to really be considered thinking about is these legacy address fields. Now, I know that these are conditional. This is something that is in the transition document. The NINA data model does not instruct the vendor what fields they can use. So this is a really important part of procurement. You need to understand what data elements are going to be needed for, say, an MSAG conversion service. You're going to need to know what elements you're going to have to build a geospatially derived MSAG to replace the tabular MSAG, so you don't have to maintain both of those. So this is really important information to understand. It is very common. In fact, I have not seen a deployment that does not require from the data contributor all of the legacy street elements, ESN, and MSAG community. Those tend right now in a transitional deployment, those are required. They are not optional. And Richard, maybe you could talk a little bit, how is that being treated in the new version of the data model?
The same way, one of the things that they had changed in the model,
I don't think we can hear you,
eh,
Richard, if you're talking.
hopefully you can hear me now.
I can hear Richard.
Okay, good. So we still have the conditional field.
So
But
once Richard gets his audio stuff figured out. So
why is my audio not
it's just
working?
really
Sandy,
important to
Sandy,
note
can you
that
hear me?
this is something as a 911 authority you're really going to have to ask
Sandy?
questions about. That's so weird. I could not hear him.
Sandy, we can
You hear
hear
me?
Richard fine. I'm not sure you can hear us.
Ah,
Um,
so you can hear me, right?
Yes, we can hear you.
Okay, so let's do this. The the conditional field, we had a lot of debate on version 3 of the data model, and we had required, conditional, and optional. They dropped optional. So
let me
you
check
now
here.
have required or conditional. So conditional fills a role. One of the things they did in the definitions under conditional was stipulate that where it's necessary to fill them in, uh, because we have the possibility of folks going to the end state now, and of course, end state later, those legacy fields had to be conditional. They couldn't be required. However, as Sandy's alluded to, as I said in my presentation a while back, you have to have those fields filled in to be able to essentially translate legacy naming conventions, which has, only a few fields, 4 fields there, to the multiple fields for naming conventions in the next gen world. And even though you may have an area where you have, multiple PSAPs in your county or your region that transition over and say, oh, we're good, you'll still have to transfer calls to other centers outside of your area, which may be in a legacy format. So for Sandy and I think we would see this MSAG conversion service. And as she said, it was misnamed. It probably should have been an alley conversion service, because the original standard, which was miswritten, said you had to send an MSAG record, which is not true. You simply need to convert in a civic address between legacy and next gen format, and vice versa. You'll have to be able to provide that capability going forward for other sites in and out of your area. Sandy, I think that's what you were looking at as well. Oh, now we can't hear you. Maybe you can hear us, but we see your lips moving.
Can you
I knew I should have taken silence. Yeah. Oh, you were there for a second. There you
Okay.
go. You're back.
Okay. Yeah, no, and that's it. And we'll actually talk a little bit more about where those legacy fields are going to become really important when you are also doing the remediation work. So these legacy fields, again, while they are conditional, and Richard, I didn't hear you if you were saying in the next version of the data model there that's changing. It is really important.
What I'd say, Sandy, is they dropped from 3 categories to 2. They
Good.
got rid of optional. So
Okay.
conditional is the kitchen sink. It's like, you're required, you got to have it, but conditional, your judgment. But as I said, it is required for us who understand you're going to have to be
Yeah.
able to do that, translate between different
And
types of sites.
And again, for procurement, that does become a question you do want to ask all of your core service providers. That for geospatial MSAG, for MSAG conversion service, what data elements are required for each of these functional elements to operate? I would always suggest you ask that question. Even though you may put in there, you have to be compliant to the NINA data model. If you do not ask them what elements are required, anything that is conditional, they may require, but they're not necessarily being asked the question to detail that. So
Sandy,
I've seen that from the primary side as well. Yeah.
Sandy, one thing we don't say very much, but I think it's appropriate to mention to folks, is that each of these functional elements, like the MSAT conversion service, there's an obligation to manage them such that if there's a failure or the data doesn't perform, that there will be a feedback loop provided by the discrepancy reporting system. So the MSAT conversion service, you see those calls on screen, PITIFLOW to MSAT, MSAT to PITIFLOW. If it cannot be performed, there's a problem with the data one way or the other. That discrepancy report would serve to identify that there is a problem with a particular query. So just be prepared for that. That goes into the lump that I and Sandy have described about discrepancy reporting for those elements that depend upon GIS data to operate properly.
And I share this not because I'm trying to say that there's some people that are dishonest and not. It's just that with, having been on the side of a 911 authority, if you don't necessarily ask the question, they may not necessarily even have the avenue to give you the answer. If your question is only, are you compliant with these standards, and you list those standards, they can say yes, but it may mean that they have additional requirements that you're just not asking about.
This is Matt.
Yeah.
I've always thought of the discrepancy aspect, not in terms of, it's okay if the MSAG and ALI in their traditional form go away. That doesn't mean that that you no longer need a local data discrepancy coordinator, right? You had an MSAG coordinator. It's just shifting. You still need a local coordinator to manage those discrepancies that get reported back to you, but it's more
Absolutely.
in the realm of
Yeah.
GIS data and still liaising with the addressing authorities.
And I would say that, Matt, one of the other kind of tidbits and the bits of advice that I would tell you guys is that when people make the conversion to an LDB, and we'll talk about this when we go into the roadmap, there'll be an entire process by which the ALI records will be converted into your LDB database. Depending upon how the LDB is configured that you procure, and there's several different, flavors on the market, anything that does not convert against your GIS data, meaning it can't find that address in your legacy fields, it's going to kick it to you. Now, what we know from a lot of our customers is that about 60 to 70% of the ALI records that cannot match your GIS data are actually issues with the ALI record, not missing addresses in your GIS data. And so you will end up going through a process, if you're not careful, of cleaning up an entire LDB database. And if you do not have the mechanisms in place to ensure that the OSPs are also making those corrections on their end, then when they convert their data to a list, it'll happen all over again. Because right now there's one discrepancy report, and it's a GIS discrepancy report. So anything that can't be found in the GIS data comes back to you on the 911 authority side. It does not go back to the OSP because it does not know where the error is. So going back to, again, this value of the ESC. So as I was sharing with you, one of the things that we did in Minnesota was that we collected ESCs. We found this to be really helpful for things like edge matching. But I'd also say that there's, and I'm going to come back to this slide, there's some other really interesting uses of an ESC. So the edge matching, having to do edge matching one time between a 911 authority instead of for each separate boundary, right off the bat, that was reason enough for people to go with this approach. One of the other things, and I'll come to Alex's question when I'm done with this. One of the other things is that there is a topology relationship between your roads and your addresses in every single one of these boundaries. So there is a requirement that your road center line is broken at every single boundary change. And that is because if they are using a road center line in that ECRF, so if they're taking that civic location and using the road center line, that call, that it has to pull the URN from the correct PSAP boundary. So there is a topology relationship. We did build in some, we built in some validations to actually look at the ESC and the road center line and the address point to really kind of ensure that. So here's some stuff that maybe isn't talked about very much. So one of the other things about the ESC is that MSAG community, is we're hearing out in the wild, is sometimes used for default routing. If you don't have, so having that MSAG community boundary, if you're not able to find the exact address, but you're able to find enough information to get the call, MSAG community can sometimes be used for default routing if that's all the information or the level they're able to get to. One of the other things is as an ADR. So I'm going to go back to this field. There's nothing that says an ESC only has to contain elements for fire, police, EMS, and PSAP. You can have, if you have an interest in having additional service boundary areas, so things like animal control, I know, or parking authority. In Minnesota, we had, in a lot of our really rural areas, and this may apply for Colorado, we just had a first responder, and they were responsible for fire and EMS. So they just had a law and a first responder. Well, that information is not as easy to capture and maintain if you have all these different boundary files. But there's nothing that says that you cannot have an ESC that has all of these different relational multi-part polygons in it. You can interpolate that information out of. And what that ends up becoming is a source that can go into an additional data repository. So one of the things about that's just kind of lovely about an ESINet and a core services system is this is no longer a one-way push or a one-way query. You at the 911 side will have the ability to use an address or use a phone number, a TN, to query back into an additional data repository that is part of your ESINet that will give you more intelligence and information about the caller or the location that the call is coming in from. So there are all sorts of examples of different types of ADRs. It could be critical population database where people submit information about whether or not they have someone who is deaf or hard of hearing in the house, or they have someone who's on a ventilator. This is all information that can go into an ADR. So having some of these service boundaries, while they're not part of PIDFlow, they're not sent with the 911 call, they definitely can be information that you store and share. Yeah, so Alex, you're talking about this process that you guys are going through. And I agree. I think we have started asking, we actually were talking with a wireless provider last week, what are they going to do when an LDB goes away and they're no longer storing peonies or have that, that information to be able to rely upon. So I would say that your comment is, do not discount the amount of time and effort that is actually going to go into this process. I don't know if you want to add any more.
No, I'm good. Thanks.
Okay.
It's yeah, it takes a long time. So be
It does.
expected for the hiccups that come along with it.
And I think what Alex is saying actually really supports this roadmap. So we're going to spend a lot of time talking about the different stages of the roadmap. And I think one of the things that this webinar and this webinar series represents is part of stage one. It is addressing the GIS and the data pieces kind of in that first step. So I would say that the education for when we look at stage one, it's not just about technology. The education and the coordination pieces are going to be critical. You're going to need to be able to work with your neighbors on those boundary alignment. So having these work groups, having these committees, it is super important to have that stakeholder feedback coming into the 911 authority. Anyone who's making purchasing decisions about tools or solutions, you know, the end user really is one of the most important voices there. Having the education. Beyond just webinars, though, start attending conferences. Going to conferences if you can, go to one a year. Standards and Best Practices is a great conference. If you, even if you are not part of a standards committee, you will learn so much at those conferences, just hearing everyone talk about what's happening in these standards. Richard, I don't know if you want to add any more to that, but I think that conference I probably walk away with the most information from.
I would agree. The venues in which we discuss what is ongoing and what's been learned is usually worth the time to invest in those sessions. You know, we have the National NINA, as we've spoken about, and the National NINA Conference will have a lot of different things to attend, but the Standards and Best Practices Conference, which will come up later this year, is a phenomenal opportunity. As Sandy said, we present there. We usually discuss some of the challenges with the technology. And I want to say it again, what Sandy has said, what I've said before, it's an evolution of public safety. We're going to take half a century of old technology and try to evolve it in just a short period of time. So there's going to be a learning curve. At the same time, we have a change out of the old guard for the new, all the people who've been at the telcos and OSPs and local governments for years and years and years. They naturally evolve into their own other careers, and we have new people come through the ranks. So making this education component first and foremost an important aspect of getting on board what we're doing here, we feel is absolutely essential to any successful deployment.
And I just want to be mindful of time, Richard. I'm going to kind of go through some of this a little bit. I'm not going to read through all of this. You will get this information. This is really a step-by-step what you should be doing in order to really sustainably be cleaning up GIS data. Again, looking at what is needed, looking at those the conditionality and what might need to be actually required, focusing on required elements in CLDXF, and then doing this legacy to GIS comparison. It is not a synchronization, it is a comparison. You just want to be able to make sure that your address data can answer the same question as the MSAC. So I promise you, let's take a look at some PIDFlow elements. So this PIDFlow object is what the telecommunication provider is going to send to the LVF to do an LVF verification. The LVF is going to be powered by your GIS data. So when we break down what's really in a PIDFlow object, it just is the exact same match of the elements that's in the GIS data model and the payload or the information that is guided by CLDXF. We're just doing a one-to-one match. This is not geocoding though. There is no fuzziness. There is no approximation. It goes line by line. So an LVF validation goes A1 to A1, A2 to A2. When it hits an error, it stops validating. So in this situation, every single one of these PIDFlow object elements was able to be found in a site structure address point. So that is a valid LVF. That element can go into a list database. This is an example of an invalid. So in this situation, they are using an abbreviation for street type and post directional. That would stop at the street type. It would return an error. It would say what field it stopped at. It will not tell the OSP how to clean up their data. It will not tell them you used an abbreviation. This is what you should be using. This is a big misconception right now. So as soon as you can start working with your OSPs on doing the ALI to GIS comparison and getting their data cleaned up, helping them understand what they're going to have to do once you make that phase 2 request is really critical and important. So what's also important to know is that if your GIS data has information that the PIDFlow does not have, that will also be an error. So if you have address points and you have subaddresses, but you do not have a primary civic address address point for that location, and that is what the PIDFlow object has, it doesn't have the subaddress or the dispatchable elements, it will also fail. So this is where it does, why you have that discrepancy reporting that's done as it is. But then also you have things like if the PIDFlow object, if they send in a location, so a common place name, and that's not information in your address point database, that will also be rejected. So again, this is not just a, the cardinality, it has to be 100% or else it will not be a valid LVF. So in stage 2 of the roadmap is to procure your core services. But then also then what you're going to want to do is you're going to want to file your FCC phase 1 request. The phase 1 request does not have anything to do with your GIS data. What it has to do with is you no longer have to pay for 2 networks anymore. So getting those legacy selective routers decommissioned is only going to provide a more sustainable network. It's going to provide a quicker call routing. One really key thing I want to point out here, though, is that the language in the FCC report and order does say that your POIs have to be stored in state. Now, you can always negotiate with your with your OSPs, but if you do not want to do that, please make sure that when you are procuring your system that you have your POIs in state, your SIP POIs. So stage 4 in the roadmap is your LDB conversion and conformance. So like I was saying before, you want to make sure that your LDB is helping you make this progress down to being able to decommission the LDB. And so some of the questions you may want to ask is the data at rest in the LDB, legacy, and CLDXF. And there are some that are, it's not just one. Are those records being LVF validated when the LVF comes online? So what that then gets you to is the point where you can make an FCC phase 2 request. So what Alex was talking about, this isn't just like a one-time thing. As you are working through cleaning up an ALI database, you should also be creating this 911 database that has data in legacy and CLDXF, because you're working on that with your OSP, and then you can make a phase 2 request. So once you've made your phase 1 request, you've gone the year in operation, then you can make a phase 2 request. I apologize, Matt, I did use some acronyms. The phase 2 request, what's the important part here? This is where the commonly accepted standards come into play. There are only 5 commonly accepted standards that apply to what the FCC has said, and we have talked about all of them today. PIDFlow, CLDXF, the NINA data model, and I3. So when you make this request, you are saying, I, 911 Authority, am expecting you, OSP, to become a database provider of your own data, and you are going to follow these commonly accepted standards that I am using in my GIS data. So this is why getting to I3 is important. You will have a cost elimination. You will have greater interoperability because that location data, that information's conveying with the call. But then also we can build the next gen 911. So in order for us to keep innovating with 911, we have to be able to get everyone to a certain state, and then we can go to the next state. So I will stop there. I know we are at time. I didn't know if anyone had any further questions or comments.
Looks like Alex has his hand up.
Yeah, and hopefully it's just a little quick one, but you had mentioned with sub-addressing data and the conflict with CLDXF fit validating. That's a common thing we see with just the legacy system of, telecom providers not creating a record with sub-address info, and then, it struggles to map. But can you talk about how you've seen that process work and people cleaning up?
So I can tell you there is one interesting example. The state of Massachusetts, the Commonwealth of Massachusetts actually has an LVF that is supplied with address points that have sub-address elements. The reason for that is they have some state law that requires all MLTS providers to LVF validate their 911 databases. So that goes back to Ray Baum's Act. The problem, and so I think that, to your point, The question really has to become, do you want subaddress elements LVF validated, or do you want just the street address LVF validated? This is an important consideration when you are procuring a system, because you will, if you want to be able to make that flexibility and to say, I only care about the street address being LVF valid. Now, the problem with that is that if they don't, there's two key things just to kind of touch on with the PITA flow. There's having the information in the PITA flow match your GIS. There's also actually constructing the PITA flow object correctly. What I can tell you is that most PITA flow objects I have seen up until this point are not constructed correctly. They put all of the elements into the RD field, and that's going to fail automatically. Now, if they were to send the 911 call with that, the problem is the MSAG conversion service couldn't even use it to convert the street address field. It wouldn't be able to display that in your call handling equipment. So my recommendation is always, when you are going through even starting that alley cleanup work, begin working with your OSPs to have them begin to understand what this path actually means. And that at the end, you have an expectation, but set those expectations even in a policy at the state with your committees. If you guys decide, okay, we're only going to validate the street address, then that becomes something you can work on with your OSPs, help them understand how to construct that PITA flow object. And then also, that can be something that you negotiate as part of your phase 2 request with the FCC. There's nothing, and I think that there's a lot of conversations right now happening around dispatchable location and those subaddress elements as to whether or not those really should be things that are LVF valid, because the FCC rules right now say only the street address has to be valid. So
Just
if you
as a
do want to hear about some real world information, the Commonwealth of Massachusetts is actually dealing with it, and I do know it's a big old pain for them.
just as a follow-up to that, so in the instance you're saying, if it's just the street address validating because it has to match exactly 1-to-1, does that mean for any like apartment complexes that have a bunch of sub addresses, there's going to have to be a parent address point with no sub address on it?
There doesn't have to be a parent address point if your road center line can actually validate it.
Okay.
Yeah.
Or-
So that's where I would say you just want to make sure that, again, you're procuring an LVF that will do a cascading to where if it doesn't find it in the address point, it can find it in the road center line. The turnaround time of instantaneous isn't quite as important when you're talking about the LVF. And Richard, I don't know if you have anything else you want to add to that, because I think you've been down that path before, where some systems are not configurable that way.
Yeah, as I said, as we evolve through this, we want to maximize the use of available data and use the best available data. So if we have sites that have work they've done on address points and road center lines, we want to be able to utilize that information. We can do cascade approach where we do searches through multiple levels of data. There's a variety of different things. Plus, it needs to be understood. You may have a data contributor for 2 parts of a county from 2 different providers where you all have to search. One could have address points and one could have road center lines. I mean, there's just a way we need to look at the data availability holistically, have that functionality, which can go either way, is configurable. Not to mention an offset. That's not even mentioned in NENA standards, although we're starting to speak to it in some of the documentation that I'm helping co-chair, where we say, okay, yeah, you have a specific location, you want a geocode on the street, how much are you offsetting it by? 1 foot, 10 feet, 50 feet makes a difference in which jurisdiction it falls in. So what we've tried to explain to people who are building their GIS data, and Matt, you and I've talked about this before, you have to understand as a GIS practitioner, you are baking in intelligence into your data. So you build the data, if it's used for next-gen purposes, so that it functions a specific way, particularly along roadways and easements where you have both address points or center lines to contend with. So yeah, the LVF has to be flexible to support that, as well as the ECRF.
I feel like on the road center line versus address points issue with respect to sub addresses, the other question is, if your core services are not yet able or willing to match to sub-address data,
Right.
Yeah.
then you have to ask yourself, are you okay with the level of location precision that road centerline geocoding is going to create as an estimated location, as opposed to putting in essentially an additional false address point at each subunit, sub-address location so that you have a more precise result for the LVF outcome.
And since for now, we see most of those locations are not coming in with sub-addressing. The legacy databases don't contain enough information. You have an add loc field, additional location information, but you don't have a structured series of sub-addressing. That's one of the whole points of having CLDXF, that you can have that very granular approach to location information. If that's not coming across, it won't matter. You're just going to go ahead and figure out where it falls along a road or find an address point for it. And the truth of the matter is, a lot of the proprietary solutions, they'll search it by database first. They'll go through largest to smallest geography. Are you in the correct county? Are you in the city or the unincorporated area? Okay, what's the name of the road? For the less than 10% of the searches that are civic related, out of those, 99.99% are going to be located on the road name by itself. You may not even get to need to geocode an address point or a on that road range. Even if you did, 9 times out of 10, if you're building that data, you're going to build it so it falls in one responder jurisdiction or the other. Same for the responders, fire, law, medical. So by and large, in my opinion, we're not going to get to the necessity of sub-addressing unless it's split by geography, a golf course, a waterway, a thoroughfare, where you may have the same location on different sides of those, and maybe you do need an address point. Where it's really going to come into play, which we're not ready for, is 3D, when we need to have perhaps different routing based on if you're on the bridge above the waterway or you're on the waterway. Maybe there's different locations it goes to, maybe different responders, but we're a ways from that.
Yeah, and I would say these are just things to consider as you are making this transition, because the amount of time and the cost associated with creating a GIS, full address point data set with all those sub-address elements. If, to Richard's point, most of the time, if ever, you're going to use anything past the street name, and the range and some other information, then really it may not be something that is needed before you can deploy your system. What I'd also suggest is that there are a lot of conversations happening in the kind of in certain groups around the viability of using indoor maps for LVF validation for sub-address elements. So we have a
That's true.
lot of
And
indoor mapping that's happening right now that is
yes,
CLDXF compliant, that does have that sub-address information in it because they're mapping the interior of buildings. When you combine that with the potential and the flexibility to use that for an LVF validation, you then get to a point where you're not necessarily having to have an address point layer that needs to be used or supplied for that level of granularity. So I
I'd like
think
to
that
leave you
there's,
with.
yeah, go ahead,
Go ahead.
Richard.
I'd like to
No, no,
leave you with two things before Sandy wraps up. One, just breaking, the GIS data model is complete. It completed its adjudication of public comments. It will not need to go out for a second public review. It's about to be in the hands of NENA leadership, which means we will see the final version in just a matter of weeks after it has that soak period internally. So get ready for the V3 version of the data model to come out imminently. When we look at the 3D, as Sandy's talking about, I'm a member of that 3D standardization work group where we're trying to build out the standards for 3D and interior mapping. That'll be a little while, but we'll have something that'll provide all the industry guidance on what some interoperable and base element structures we need to have for the industry to standardize that. So coming along for the base data guidance you need.
That's
I was just going to say,
outstanding news about the
oh, go
data
ahead.
model. Sorry,
Yes.
Sandy. We've
No,
been,
no,
I
no,
just
that's
found
fine.
out. I just found out an hour ago. So
our group over
Deb
here.
Roseboom said they're done. They got it done in one day, the adjudication. They just didn't have many comments. So
That's
now it's in
amazing.
Neva's hands. They'll turn it around, put polished, boom, stamp it with a big rubber stamp, post it online. We'll all get a notification when that happens.
Thanks, Richard.
And just one more kind of tidbit on that, I would add kind of with that new news information, Richard, is when you are going out to procurement for anything that's using GIS data in 911, ask the question of how your vendor handles the
Absolutely.
migration over to the new data models.
Absolutely.
Because you're going to want to know that in the sense of what might be expected of you as the data provider, but also you want to know that they are going to make that transition at some point if that's something that's important to you. So we're at the end of time. I know we had to rush through some of this. If anything we talked about, if you have any questions, please don't hesitate to reach out to us. Also, we will be at NENA in a couple weeks. Richard and I will both be there. We are happy to dig into all of this with you guys. You know, just from we do love to be able to geek out on the technology and the data. So don't hesitate to come find us and ask any questions you may have.
We love to share.
Thank you so very much, Sandy and Richard, for this presentation. We very much appreciate it. I took down the questions that were asked, and this is also recorded and will be put up on our YouTube channel. Thanks for joining us for the GIS Informational Series Session 2, and Session 3 will be on Thursday this week, so be sure to tune in for that, and we'll see you next time. Thanks, everybody.
Thanks, Sandy. Take care, everyone.
Thanks, everyone.